Okay, good afternoon. So now we are starting with the examples of your map reducing programming model. Okay, so some of the examples which you have to show how the flexible map reduce is going to be make use of. The first example which we are going to discuss is distributed graph. Okay, so in the distributed graph, how it is going to handle here is so that is distributed graph is operation as you have already gone through that particular command in your Unix. Okay, so a grep is a command which will search for a pattern, particular pattern. So now here also the same thing. So the grep operation which performs the recognition of pattern space text streams. Okay, so it is going to be performed across a wide set of files. Okay, and whatever the map reduce you are going to make use of when you want to match the pattern. So it is going to leverage to provide a parallel and fast execution of this particular operation. By using the map reducing technique, you are going to we are going to have the faster execution of this particular operation. So in this particular case, what will happen is, so a plain text file and a map function emits a line into the output each time, and it is going to uh, recognize the pattern. So recognize the pattern. After recognizing the pattern, so the reduce stack, what it is going to do, the reduce stack is going to aggregate all the lines emitted by the maps task into a single file. That means if you are considering one word or in that particular sentence, it is going to take that particular word in the n number of sentences. And in the reduced phase, what will happen? All these words which has to be supposed to be detected, that particular word will be corrected together and it will be mapped it. Okay, so that's what it is going to do. So the next we are going to have is count of URL or access frequency. So when you are going to have the Mapreduce is used to distribute the execution of web server log parsing. So what do you mean by a web server log parsing is the next thing. So in this particular case, what will happen? The map function takes an input. Okay, takes an input, the log server, log of a web server, and emits into the output file of a key pair URL, comma 1 for each page access recorded into the log. So now it will give you that how much time that particular person is accessing that particular website. Okay, so how much time that particular file has that particular web browser web has been accessed by that particular person. So in the reduce function, what will happen? The reduce function aggregates, that is, it is going to combine all these lines by the corresponding URL. Okay, so it is going to correspondingly URL, thus summing the single access and outputs, a URL of which is of a total content pair. Okay, so next we are going to have the reverse web link graph. So as the name indicates, reverse web link graph. So now whatever the you are going to have the number of pages. Okay, so from that particular pages, it is going to divert to the some other link. Okay, so that when it is going to have the reverse web link graph. So reverse web link graph means what? So you are not going to type that particular link in the web browser. Instead of that one web browser will be having the link of that particular page. Okay, so then through which are the pages is diverted to that particular page. Okay, so you have one main page. From main page, for example, if I have the SVC college, from the SVC college, I'm going to tell you that you are going to access the computer science department. So that means inside your SVC page, the page which has to be opened is your computer science department page. Okay, so like that. So it may be a number of links may be there in the world, so which will be referring to that particular person, that particular page. That is indirect link which you are going to have. So that you are going to have the indirect link. So now when you are going to have that particular indirect link which you are going to have, so the web page, what it is going to do, so all these web pages is going to be collected in terms scanned, and it is going to emit it with respect to the target and the source. So here when you are emitting the source, so it is going to be so here in this particular page, so input files are simple HTML pages, okay, that are scanned by map task. So that will be usually emitting the with respect to the pages and sources. Okay, so it is going to be emitting with respect to the pages and sources, which is going to be happen here, the target and source space which you are going to have. So it is going to search for the pair of each of the links found given the web page source. So now in the reduced page, what it will do in the reduced phase, it will collate all the pairs that are have the same target. That means which page is having that particular site to be assigned. So for example, so if I tell that one, So for example, I have the in SVC page, it is having diverted to Department of Computer Science. Okay. So now, for example, I am as a faculty, I may be having some on my browser page will be there. Even that when there also I am going to divert to Department of CSC. So like another person may be there, our HOD is there. Even the HOD has his own page. So that it is also diverting in that particular one link will be there that will be diverting to Department of CSC. Okay. So that's what it is going to have there. Okay. So now here it is going to find. So here the reduce task which collect all the pairs. Okay. The reduce task is going to collect all the pairs that have the same target and the list of source files. So final result will be given in one or more files containing this mapping. So that is where you are going to make use of this particular Mapreduce technique. So next is your term vector per host. So term vector per host, it is nothing but it recaps the most important words occurring in a set of documents. So how much time that particular word has been occurred with that particular document. So I'm going to have the document. So and then I'm going to have a particular word, like if I have the keyword cloud computing, for example. So if I have the cloud computing, so it has to give me that how much time that particular cloud computing is encountered in that particular document. So that is frequency of occurrence of that particular document. So that should be there. So where that number of occurrences of a word is taken as a measure of its importance. Okay. So it is if you talk about the MapReduce, it is mainly used to provide the mapping between the origin of a set of document obtained as the host component of the URL of a document and corresponding term vector. So here, what your MapReduce is going to do. So in this particular case, in your term vector per host, so the map task creates a pair. What is the pair it is going to create? It is going to create the pair of host and term vector. So you can see it here. It is going to create the pair of host and term vector for each text document. For each text document, it is going to be retrieved. And the reduce task, what it is going to do? The reduce task is going to aggregate. Okay, the reduce task, what it is going to do? So wherever that particular word is going to be encountered, so that is going to list it out. Okay, once it is listed out, it is going to count how much time that particular word has been repeated, so that it is going to take, and it will be displayed. Okay, so into the from the corresponding documents, which that particular document is retrieved from the host. From that particular host, it is going to be retrieved. Okay, so that is what it is going to do. So next is inverted index. So in the inverted index, what it contains, basically the inverted index contains the information about the presence of words in the document. Okay, so that means you are going to have the word, so you're going to have the index. Okay, so it's going to what this particular index contains. Index contains the presence of words in the document. So that means type of word that is present. So type of word that is present in that particular document. So this particular information is useful to allow fast full text. So if you take this particular information, this information is useful to allow fast full text searches if compared to direct document scan. So this particular inverted text, what it contains, so it is going to do the indirect way of scanning the document, and it is going to retrieve the word which is be getting. So in that particular case, what will happen? The map task takes an input as a document. Okay, and it is going to from each document, it emits a collection of word for that with that document ID. So that means I am going to may have the documents. So I am going to have the doc 0, doc 1. So that maybe a number of documents will be there inside that particular distributed system. When you are going to have a particular word, for example, if I have the word, for example, cloud is there, that is will be a keyword. Now it will search in the document 0. Maybe the occurrence of the cloud is around 12 times, and in document 1, the occurrence of the cloud will be around 9 times, and document 2, the occurrence of cloud, it was in 5 times. Now in the reduced phase, what will happen? In the reduced phase, so it is going to list how many times that particular cloud has been occurred. So the cloud is occurring at how many pages? It is 26, and it is going to list all the documents like that wherever it has encountered with that particular document. So that is document 0, it is going to list out. Document 1, it is going to list out. Document 2, it is going to list out. This is the list, and this is the word which it has been found. So the words which has been found in this particular documents which you are going to have. So that will be in your inverted index. So when it comes to a distributed sort, so now whenever you are going to discuss about the distributed sort, in this case, what will happen? The Mapreduce is going to make use of the parallelizing the execution of a sort operation. It is going to do what? It is going to sort of the execution of a sort operation. How it is going to do? So it is going to search for the entire record. So it is going to search with respect to the sorting. It is going to do the sorting. The sort operation is going to perform with a large number of records. Okay. So now what the map task has to do now? So the map task extracts the key from the record, because when I'm searching any data, I should have some key, right? So if I'm going to have the particular student, for example, in a class where I need to search. So for example, with respect to USN, I'm going to search it. So that will be your ID, right? That will be your key ID. So key ID, I'm going to take it. So once you take the key ID, so you're going to have a number of database or record. So that particular USN will be there in your first semester mark sheet also. That particular person, if it has the back, the second semester mark sheet also, that particular person's USN will be there. For the third semester also, it will be there. Fourth semester also is there. For all these 8 semesters, that particular record will be there. So when you are going to have that particular type of record, the map task extracts the key from the record. Okay, so from that particular key, that is wherever it is encountering the USN. So wherever it is encountering that particular USN, that is going to extract that particular record. So if we talk about the, for example, I have one ME 19 CS 011 is the USN which I want to search. Now it is going to search. When you are going to search, so it will be available in first sem record. It will be maybe it may be available in the second sem record. It may be available in third sem record, or it may be available in fourth sem record. So it may be available in fifth sem record, sixth sem record, seventh sem record, and eighth sem record. Okay. So like this, it will be stored in different, with respect to the different record, with respect to the key. Key is your USN number. And the Redis task, what it will do, it simply copy through all the pairs. That is, it is going to check that key pair. So that is, it is going to search for 181 first sem, 1211 second sem, in third sem, fourth sem. So both the key as well as the record, it is going to take. So in this particular sheet, so it's completely copy through all the pairs. So the actual sorting process is performed by the Mapreduce runtime, which will emit and partition the key value pair by ordering them according to the key. So here the key value is nothing but your USN number. So with respect to the USN number, the partition is going to do, and according to the key that will be listed. Okay. So next, when you are going with the in general, what will happen? So the computation can be expressed in terms of 2 major stages. Okay, so if you talk about the computation, so that is with respect to a distributed sort. So the computation can be done with respect to the 2 major stages, which can be represented in terms of Mapreduce computation. Okay, so if I am representing with respect to the Mapreduce computation, what are these stages comprises of? So these stages, which is going to be comprises, one is your analysis part, other is your aggregation part. So what is the analysis part? So the analysis part is nothing but, so it is the step where it is going to operate directly to the data input file. So this particular phase, it's going to operate directly to the data input file, and it going to corresponds to the operation performed by the map task. Okay. So when you are going to have in the analysis stage, so that particular computation which you are going to have, the computation of this particular stage is expected to be a embracingly parallel application. Okay, so it is going to have the embracingly parallel. So embracing the parallel is nothing but what? So the function what it is going to be implemented, it is same. The functionality is same. Okay, the functionality is same, but the data which you are going to send is different. Okay, so that's why in this particular analysis phase, what will happen? So since it is the data what you are sending is different, and the functionality what it is going to perform is same, so that may be done with sequencing or ordering. So that parallel applications, I can do it sequentially also, or I can make that particular operation to computation can be done with respect to the parallel stage also. Okay, next is aggregation stage. So aggregation is nothing but what you are going to combine it. So whatever the result you are going to get, okay, so whatever the operation you are going to make it, so the phase operates on the intermediate results which you are going to obtain. It is going to obtain with respect to the intermediate result. So you're going to have the intermediate result, and whatever the result it is going to have, so it is going to be determined by the characterization of the operations. So now once you are getting the results, all these results are aggregated together. So all these results are aggregated together, and it will be summed up. Okay, and it will be summed up and are elaborating the data. Okay, and are elaborating the data obtained at the previous stage. Okay, so it will be obtained at the previous stage to present it into its final form. So whatever the data you are going to obtain, so that will be presented, so in its final form. So this is the task performed by the reduce function. So it is going to have elaborated the data and obtaining the previous stage to present it into its final form, and it will be performed by the reduce function. So this is what the Google Mapreduce infrastructure overview is going to tell about. So you're going to have the input files. So you can see it here. The input files which you're going to have is split 0, split 1, split 2, split 3, split 5. So there are 4 or 5 different files are there, or those files will be there. Then it will be assigned to the worker. So it is going to assign to one worker. Split 2 is assigned to one worker. Split 4 is assigned to one worker. So another split 1 will be given to the intermediate files. So your split 1 is going to have with respect to the intermediate files. Okay, so this one. Now once you have this one, so the master what it is going to do, so it is going to assign. So assign to the map. So the mapper work is going to do what? So that it is going to assign to map. What map it is going to do? So for example, if I want to create another process, so the fork is a command which is used to create the fork process. So it is a command used in your Linux. Okay, fork is a command used in Linux, or Unix. For what purpose they have been used? So they are used. The fork is used to create the process. Fork is normally used to create the process. Okay, so one fork, if you specify, one fork is going to create two child process. One fork is going to create two child process. Okay, so once it is doing the two child process which you're going to have, so the worker which you're going to have here. Okay, so the worker at the worker node at the receiving end, that is in the reduce phase. Okay, so in the reduce phase what will happen? So whatever the happen or whatever the assignment assign has been done, so that will be assigned, and it is going to retrieve that particular work assigned reduces. So what is the assignment it is going to have? It is going to be after in the at the input output file, it is going to reduce it. So reduce to a particular property with respect to the key. That is, it is going to particular key. It is going to bifurcate. So after having to the particular key, okay, so it is going to reduce it, and the output file 0 is going to be obtained. So that is going to be happen in your output files. So next, when you start discussing about what are the different variations which you are going to have. So here, with respect to the figure, if you take, so what are the different process it is going to happen here is the next question. Okay, so here, if you take, so just I will erase the content. So here, what will happen? So the abstraction which you are going to have here in this particular figure. So the abstraction produced by Mapreduce, what it's going to provide developers, it is going to provide with a minimal interface. So the abstraction or the idea which you are going to have, so that is going to provide you the minimal interface. So how it is going to provide you the minimal interface? That is going to provide the minimal interface with the help of the algorithm which is to be implemented. Okay. So rather than the infrastructure on which it is executed. So totally depends upon the algorithm which you are using. Okay, it totally depends upon the algorithm which you are using rather than the infrastructure on which it is being executed. Okay, so now once it is executed, so this particular implementation using your algorithm to do the computation, so it is going to provide you the effective approach. Okay, at the same time it is going to give you the effective approach. So which demands a lot of common tasks. So that means the same task will be repeated again and again. So if you are repeating the same task means what? Same functionality. So the functionality is same, but the data which you are going to send is different. Okay. So that is how the user is specifying the configuration parameters. Now, from the figure, you can see that first the user submits the execution of Mapreduce in jobs by using the client libraries. Okay. So, and then that are to be changed of submitting. So once you have been submitted to the input files, so then the registering the map and reduce functions and returning the control to the user once the job is completed. So here the user program is there, right? So the user program is going to create the fork. So fork is nothing but what? So it is a child process which has been created. Okay, so the child process is created there. So once the child process is created, it will be created by the client address. So that are in charge, the client process which you are going to have. So that will be in charge for submitting the input data files. So now how it will be done? That will be registered by using the map and reduce function. Once it is done, so if you are going to have the generic distributed infrastructure here, okay, so that is if you take the cluster as an example, basically it is equipped with job scheduling capabilities and distributed storage. Okay, so you are going to have the two different kinds of process which will be running on a distributed infrastructure. One is the master process, other is the worker process. Okay, so you are going to create the two different process. One is the master process, other is the worker process. So fork you are going to create by the user program. What it is going to create, the fork when you are doing the child when the user program is creating the child process, one process it is going to create the master process. The other process it is going to create the child process. So now what is the purpose of master process? So now the purpose of master process is in charge of controlling the execution of map and reduce task. So if we take here the map master process, here the master process, this particular process is in charge of what? It is in charge of controlling what? It is in charge of controlling the execution and so it's in charge of controlling the execution of map and reduce task. So it is going to be in charge of the execution of map and reduce task, which you are going to have here. Okay, so that has to be done. So here the master process which is there. So next the worker process which are there. So basically they are used towards the execution of map and reduce task. The worker process which are there are used towards the execution of map and reduce tasks. So this worker process are there in between. So that will be helping in your whether that has to be done the map task or whether that has to be done the reduce task. And it also basically provide you the IO facilities. So it is also providing the IO facilities that user to interface the map and reduce task with input and output files. So in this particular Mapreduce facilities which are there, so the input files are generally divided into splits. Okay, so that is split 0, split 1, split 2, and it is going to be and stored in the distributed file system. All these splits are stored in the distributed file system. So you can see it here. The split 0, split 1, split 2, split 3, split 4 is there, right? So all these things basically, so it is basically stored in where? So basically stored in distributed file system. The split 1, split 2, split 3 is basically stored in the distributed file system which you are going to have. Okay, so once you are done with respect to the distributed file system here, okay, so in the map radius computation, so your input files are initially divided into splits. That may be, it may be generally in terms of 16 to 64 MB, and it is going to be stored in the distributed file system. So now the master process which is there, the master process what it is going to do, so it is going to map the task. Okay, it is going to map the task and assign the inputs list to each of them by balancing the load. So your master is there, right? So that master what it is going to do, it is going to assign the split. Okay, so it is going to assign the input split to each one of them, each one of the worker, by having the load balancing. Okay, yeah, it has to do the load balancing. Yeah, because this is when you talk about the cloud, the data which you are going to balance, it should be proper. Okay, so next, what will happen? What the worker process has to do? So now the worker process will be having both input and output buffers. So that are basically, if you take the worker, so worker will be having both input and output buffers. So here also input and output buffers it is going to have the worker. So what is the purpose of this particular input and output buffers? So they are basically used to optimize the performance. of map and reduce task. So in particular here, what will happen? The output buffer for map task are periodically dumped into disk in order to create intermediate files. Okay. So here the intermediate files are partitioned by using the user defined function. Okay. It will be splitting evenly the output of map task. So that is what it is going to do in your map function. So next, when it comes to the intermediate files, so here are the intermediate files which are there. So the intermediate files which are there. So that will be partitioned by using the user defined. That will be partitioned using the user defined function. Okay. So that will be done. So normally it will be done by via the remote procedure call. So it will be done. So the user defined function, it is going to be done. So if it does have the user defined function, the user defined function normally which you are going to have, so that will be performed by having the so the location of three pairs are then notified to the master process. All this whenever the master task, so output buffer of map tasks are periodically dumped to disk in order to create intermediate files. So this particular intermediate files which are there, that will be done using the user defined function to split evenly. Okay, so user defined function. So what it is going to do, so that will be splitting that data evenly across all the nodes. So it is splitting the data evenly across all the nodes. So now, so the locations of this worker, because the worker will be located all over the globe, right? So when the worker is located all over the globe, so the master has to tell that which worker is located in which place. Okay. So the location of these three places that was notified by the master process, which forwards this information to the reduced task, because all worker will be stored. All workers will be located in different place. Okay. So those places it has to be shown. So once this is showing that particular place, so the location of these places are then notified to the master process. So we forward the information to the Redis task. So now the Redis task which is there, which are able to collect the required input via remote procedure call. Okay. So before orchestrating the execution of map and Redis task as described before, so the MapReduce runtime ensures what? So the MapReduce ensures that it is going to ensure a reliable execution of applications. So if you take the MapReduce, so it is going to provide you the reliable execution of the services. It's going to provide you the reliable execution. Okay, so it is going to provide the reliable execution of service. It is going to provide by how it is going to provide. So the provide reliable service it is going to provide. Okay, so reliable execution service it is going to provide. How it is going to provide? So it is going to provide by having the fault tolerance mechanism. So whatever the provide level execution it is going to provide, so it should have the fault tolerant mechanism will be there. Fault tolerant mechanism will be there when it is fault tolerant provisioning is there. Okay, so that will be done. So now here the failures of both master and worker process handled as the machine failures that make intermediate outputs not accessible. So next, there may be a case that your master also goes down, your worker may also go down, because when you talk about the computers or the node, so it may go down, right? So when it is going down, so what it is going to have, so here, so the location of this place is notified by the formation reduce task, and the key range is then sorted and it is going to be retrieved. Okay. So now here the worker failures are handled by the rate scheduling map task. So if any of the worker fails, so if you take this particular workers, so if any of the worker fails, so now again if it fails, it has to work again, right? So if it is failing means what? It has to work again. So now it has to reschedule what now. So after failing is occur, again it has to do the rescheduling the map task. If this particular worker works, so rescheduling the maps has to be done. So rescheduling the maps has to be occurred here. So that particular rescheduling of max is going to map reduce is going to occur. So this particular worker reference, what you are going to have. So here the worker reference which you are going to have, that will be also be determined by the that will be determined by the address machine failure here. So that will be determined by the address machine failure. That will be determined by the address machine failure. Since the valid intermediate output of map task has become inaccessible. So that means the output pairs which are going to have, that will be made inaccessible. So here, whatever the master process you are going to have, okay. So the master process failure is basically implemented using the checkpoints. Okay. So the master process failure. So the master process you are going to have. So that particular process, if it is failure is going to occur. If the master process, if you take the master process, if the failure is occurring there, if the master process fails, okay. So how it is going to address that particular failure? So I'm going to address by using the checkpoint. I'm going to introduce that particular failure by having the checkpoint. By introducing the checkpoint, I'm going to I am going to check that whether your worker is working in that particular state or not. That I am going to come to know. So now this is basically addressed by whom? It is basically addressed by your checkpointing. So after addressing the checkpointing, if any failure is occurring, okay, and what it has to do, if failure occurs, again it has to restart the job. So if the checkpoint, it is going to failure, it is going to check, and it has to restart the Mapreduce. Okay, so it has to restart the Mapreduce job. With what it has to serve, so it has to restart the Mapreduce job. So restarting the Mapreduce job with what? With minimum loss of data. So with minimum loss of data and computation. So it's going to create with the minimum loss of data and computation is going to provide, and it is going to assign the different map job to the different functionalities. Okay, so this is how is basically your scenario of Google Map infrastructure overview is going to work. Okay, so this is the infrastructure view of the Google Map Reduce. So other one what we are talking is a programming point of view. Here what we have discussed is so this particular thing is Google Map Reduce infrastructure point of view, which you are going to overview, which you are going to have here. So once it is done, so once you are going to have the Google Map Reduce infrastructure overview, so here is going to provide you the efficient utilization of the resources. So it is going to provide you the efficient utilization of the resources. So by using this one, so just I will tell. So you're going to have the user program. User program is going to create the fork. So this is two different process it is going to create. What are the two different process? One is your master process, other is your worker process. It is going to create. So now the master worker process is where you are going to map the Mapreduce technique is implemented. So and it is going to assign the job to that particular worker process. So and it comes to the master means what? So it is going to be basically in charge in controlling the execution of map and reduce task. Okay, how it is how it has to do. First, the master has to divide it. So it has to partition the program, and it has to reorganize the intermediate output and produce by the master task, which will be whether that particular task has to be run in order, whether that particular task has to be run in out of order. So that has to be kept in mind. So next, it is going to generate the splits. So these splits are stored in a different distributed system. Okay. So once it is stored in the different distributed systems, what will happen? So the basic IO facilities is going to happening there. So next, the master process generates the map task. So the master process generates the map task. After assigning the map, after creating the map task, what it is going to do? It is going to assign the input split to each one of them. Okay. So the map task it is going to generate. So whatever the split is there, that particular split is going to assign to each mapper. Okay, so that is nothing but computation. So now here also the next is the worker process. The worker process will be having both input and output buffers. So it will be mainly used to optimize the performance of map and reduce task. Okay, so it is a worker process is mainly used to have input and output buffers. Both it is going to here you can see that split input. So after worker you are going to have the output. So both your worker process will be having the If we take the worker process, so it will be having both your input and output. Okay, so it is going to have the input buffer as well as the output buffer. And so the partition will be done with respect to user defined. So the partition of task is user defined. Okay, it is user defined how it is going to work. Okay, so that's how your Google Mapreduce infrastructure is going to work. Okay, so that's how it is going to work. Okay, so that is how. So just we will stop here now. So if you have any doubt, you can ask. Okay. If we don't have a doubt, so we will just wind up the class. Okay, we'll look for the class in the next. That is tomorrow. We'll meet on 4th hour. Thank you. Bye.